again. So our today's topic for the presentation is the build chatbot on the custom data. So my name is Shivam and I am working as a technical consultant in the Tarka Labs. So I have overall 5 years of experience and I help the organization in making their apps that helps the millions of users daily. So So in this workshop, you will learn about the vector databases and text embeddings and vector similarity search. So I will start first with the vector databases. Then I will tell you about the text embeddings, how to do that and how they works. And then we will see how we can search the similarity between the two images or two textual pieces to see that how much similar they are. And later on, we will have a small project that would be the chatbot on the custom data. Right. So, what is the vector databases? Right. So, traditionally, we have seen that we have the relational databases system. So in the relational databases systems, the data is stored in the rows and columns, right? So we have proper label data, we have data with the proper rows, column names, proper data type, the proper indexes, right? So that data is kind of the structured data. And for the structural data, the relational database is a very good choice, right? But with the advancement in the internet, there are some sort of unstructured data also, that is the image, audio, and video, right? So when I say this unstructured data, so it means that they don't have some sort of the fixed format or the structure. Okay, so by unstructured data, I mean by the images, audio, and video. So these kind of data doesn't have the fixed structures, right? So if you see the image, so images have the different formats like JPG, PNG, and GIF. Similar for the audios, they have the different codecs like MP3, WAV, and similar for the videos, right? So if we want to search this type of data and if we want to query on this type of data, then the relational database is not a good choice, right? So for storing that kind of data, so we use the vector databases, right? So the vector databases is used to store the vector data, right? So vector data is kind of the data that stores additional information along with the data, right? So that additional data helps us to search the content according to its uh, semantic meaning, right? So let's say that if we want to search the image that is similar to one image, right? So we can't do that using the relational database, right? So we need to put that image into the vector database and then we can do the similarity search and then retrieve the similar image from the vector database. So let's see the applications of the vector databases. So there are some applications of vector database like image similarity search, audio similarity search, video similarity search, recommender system, and question answers. I think we all use the image similarity search in our daily life, like the Google images, right? So we give an image as a input, and the Google will give us the all the related images to our input image, right? So in the background, so there is a vector database, and on that vector database, there is a image similarity algorithm running. So second one is the audio similarity search. So in that we try to find out audio that has the related beats or lyrics, right? So one use case for that is the see whether some audio violates the intellectual property infringement or not, right? So in the audio industry, so if someone copies the beat from one audio, then there is a legal case in that. So for that use case, we can use the vector database to all the similar audio. Similarly, for the video similarity search, so if you want to fetch all the similar videos with the one target image, one target video, then you can use that. So generally we have seen that when we use the YouTube or some social media site, so when we view one image or one video, then we will see the feed that shows the similar video according to that. So for that use case, we can also use the vector database. And fourth one is the recommender system. So in the recommender system, the vector database stores all the users' activities and different events. And according to that events, the vector database recommends the content to the end user. And the fifth one is the question answer. So in the question answer use case, so we source the questions plus answers into the vector database, and according to the input question, we fetch the related question from the vector database and present the final answer to the user. So we will in this workshop explore more about question answer use case. So this is the general architecture of our application, right? So first of all, there would be a one data set that would contain all the questions and their answers, right? So in this workshop, I will use the open source insurance question answer dataset that would contain 1000 questions and their related answers. And that question answer will go to the mini LM machine learning algorithm, and that algorithm will output the text embeddings, which is also known as the vectors, and we will store that question vectors into the vector database, right? So and later on, when the user will ask some question, the similar process will happen. We will convert that question into the embeddings or question vector, and then query the vector database to find the similar question from the vector database, right? So the vector database use the some similarity algorithm and will give us the similar question and its appropriate answer. So that is the high level architecture of our application, and in the later on slides we will see how each component of our application works. So before that, uh, let's discuss what is the text embeddings. So the text embedding is the process of converting the textual data or the unstructured data into the floating point vector representation. So this is how the vector representation looks like. So the vector representation is like the um, array representation of the floating point vectors, right? So these vectors contains the semantic information of the sentence, right? So later on, when we are going to find the similarity between the two textual string, then we can use these vectors to find their distance between each other. So the text embedding is the conversion of textual data to the vector data. So there are certain machine learning algorithms developed to do that conversion. And for And for let's say that if we have some other sort of the unstructured data like image or video, then there would be a separate machine learning algorithm to do the conversion. But one thing to note here is the we need to convert the textual data into the vector data if we want to store the data into the vector database. Mm, so let's jump into the code and see how we can store the vector data into the vector database. So for this workshop, I am going to use the Milvus vector database. So Milvus is the open source, highly available, and low latency database, vector database. So if you want to create a collection, so the collection is kind of the basic object in which all the embeddings and their textual questions would be stored, right? So this is the first we need to give the collection name, then there would be the dimensions of the vector, right? And then we need to specify the uh, fields of the collection. So here we will have the three field. One is the ID, and second one is the question, and third one is the answer. So there we also need to specify what would be the data type of the field. Like for the ID, it is the varchar, and it would be the primary, and it would be auto increment, right? So that means that we will use the ID field as a primary key, and it would automatically get the value, right? So the second one field would be the question field, and that would have the data type of the float vector, and dimensions. DM is the dimension. Dimension would be 384. So so the embeddings would always be stored inside the float vector data type, right? And we need to give the dimensions of the vector, right? So the general rule of thumb is the larger the dimension, the larger the semantic information we can store inside that vector data, right? So let's say that we are storing the textual information. That's why we have the 384 dimension of vector. But if we work with the audio data or the image data, then there would be a lot of dimension number that would be greater than the 1000 or 2000. And third field is the answer. The answer is like a normal varchar field with the maximum length of 10,000, right? So this is the schema of our question answer collection, right? And this line will create a new schema, and this line collection name and schema. This line would initialize our new collection, and there are now after creation of this collection. So if we want to query or search the input question from the collection, we need to index it. Without indexing, we can't perform any search operation or query data from the vector database collection, right? So for that, we are going to create the index, right? So the create index is a function that takes the two parameter. One is the field name, the question, the field where vector data is stored, and the index param. So inside the index param, we have a dictionary that has two keys. One is the metric type, and another is the index type, right? So the index type is the flat, right? So you can think of index, right? So when I say that so index is the process in which we reorganization the data inside the collection so that it is easier to retrieve that, right? So so there are the various techniques to index the collection, and so here I will use most basic and most simplest one, which is the flat. right? So in the flat index, so whenever we execute a query inside the collection, so how it will work, so it will go and convert that queries vector with each already stored vectors inside the vector space, right? So that would be similar to the brute force, right? So the input vector would be compared to the all existing vectors inside the collections, right? So that means the we will get the results very much accurate. The result would be most familiar with the input vector, but that process would also be time consuming because we are comparing each entry with each other, right? The metric type is the similarity matrix, right? So here we are using the L2. So L2 is like a Euclidean distance, right? So similarity type we will discuss later on in the slide, right? So in this line we will create the index with the field name and index parameter, and later on when we want to search something from the collection, so first we need to load the collection, and then we there would be a question that we want to search from the vector database, and then we will generate the embedding of that question using the embedding algorithm, right? So this line will give us the vector representation of this textual data, and then we will use the dot search function that accepts the data, the vector data that we want to search, the ans underscore field, that is the approximate nearest search field, that would be the field where our embeddings are stored, and the parameter. In the parameter we need to give the similarity matrix that we want to search, uh, that we want to use to calculate the similarity between the input vector and already existing vectors, right? The limit is the one. We want to return only one result in the output, and output field, like the what we want in the output. So in our case we want only answers in the output, right? So we will first generate the embedding of the question and then calculate the similarity using the Euclidean distance, which is also known as the L2, and then answer field would be output, right? So yeah, so here the line number one, the collection dot load, right? So that means that so according to the architecture of the Milvus, so before executing any search query, we first need to load the collection into the in memory, right? So due to that architecture, the Milvus is like very much optimal and returns the result very fast, right? So after executing this function, we will have our final result into this variable, right? So later on in the demo we will see that how the result came, right? So now we will discuss what is the vector similarity search, right? So in the previous slides we understand what is the vector and how we can update obtain the vector from the different textual data, and what are the algorithms to obtain the vector, right? So now we will discuss what is the vector similarity search, right? So the vector similarity is used to find the similar vectors, right? So in the vector similarity we will define that two vectors are similar to each other or not, right? So we use the vector similarity search algorithm to say that whether two data points or the images or the textual data are similar to each other or not. So let's say that we have the two sentences, right? So we can use the vector similarity search to define whether two sentences are semantically same or not, right? So the main difference between them is So in the vector similarity search, we also consider the semantics meaning, right? And so let's say that we have this vector space. So inside vector space, we have the uh, number of vectors inside that, right? And let's say that we want to calculate the distance between A and B vector, right? So we will use the L2 algorithm. L2 is the similarity matrix algorithm that is also known as a Euclidean distance to calculate the similarity between these two vectors. Uh, okay, so let's see the demo. Mm, let me to share my screen again. Okay, so I hope that you are able to see the Visual Studio. Right, so this is the Python notebook. So inside that, I will show you that how we can utilize whatever we have discussed so far to implement the chatbot. Right, so the in the very first step, we will download the dataset, CSV dataset, right, using this command, right, and the dataset would be stored here in the CSV file, right, and in this command we will install the required library. So we will require pandas for viewing the data. The PyMilvus is the Python drivers for the Milvus database, and sentence transformers is the library that we use to convert the text into the embeddings. Right. So here we are loading the Python pandas data frame and viewing its content. Right. So here we can see in this data set we have question and the answer, right? So the question is this and the answer is this, and in this line we are establishing the connection with the Milvus database. So I have the Milvus database running in my local machine, so it will connect through that database, and this is the same piece of code that we saw earlier and discussed how to create a collection. So it has the collection name, the dimension, the fields definition, schema field definition, and this command will create a collection, and this one for the index of the collections, and here we will create the index. So there is nothing new in these lines. I have just copied and pasted from the slide, right? And so when I will execute this command, so I will output the collections, the index collection would be created inside the Milvus. Right. So I am using the mini LM algorithm to convert the textual data into the vector data. Right. So the transformer is the sentence transformer is the library that will load that mini LM algorithm into the memory, and then I will use the encode method to convert the textual string into the vector data, right? And so this is the function that is used to um, insert the values into the Milvus collection, right? The collection that we create earlier, the question answer collection, right? So what we are doing, so we are opening the question answer.csv and reading each row from that CSV, and we are generating the embeddings from the for the question, and inserting the question embedding and the answer into the database, the vector database, right? So the collection dot flush So this method is used to ensure that whatever data that you have inserted is properly inserted into the Milvus segment. Right. So after executing this query, we will try to see how many rows are there in the Milvus database. So we successfully inserted the 1000 rows, right? And then we will try to search this question from the Milvus database, right? So for that, we first need to load the collection into the memory, and then we are going to create embeddings of this question so that we can query it from the vector database, right? And then we are using dot search method that takes the data, vector data that we want to search, the field, approximate nearest field where all the embeddings are stored, and the similarity matrix that we want the algorithm that will decide whether two strings are similar to each other or not, right? And the output field that would be the answer, right? So in the response resp variable, we will get our final result, and I am printing that result, right? So here I asked one question: what is the auto insurance, right? So it gave me answer, right? So let us try to ask some another question: what are types of life insurance, right? So it gave me this answer: life insurance has two categories, term and permanent, right? So since I am using the insurance question answer dataset, so this chatbot is only capable of answering the questions related to the insurance, right? So if you ask something that is not related to the insurance, so that would not work, right? So if you want to create a chatbot on your custom data, then the first step would be is to create the data set, right? So the data set of the questions and the answers, right? So the first you need to write the script that will create the questions and the appropriate answers, right? So after that you need to insert those questions into the vector database, and the third step would be to search the input question with the already stored questions inside the vector database, right? So since vector database is the capable of the similarity search, and it is also aware of the semantic meanings behind the input and the stored variables, so you will get the related answer to your asked query, right? So uh, we will go back to the presentation. So that was the end of my workshop. So thank you for attending that. If you have any question, then you can ask me. So here are my links to the social handlers. You can follow me on the LinkedIn, and to read my blogs, you can click on this link.